Okay, so example 2, make sure you have your calculators with you. A survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to establish a relationship between low temperature and high temperature. If you look here, we have our low temperatures. Those are going to be our X values. And here are our high temperatures or our Y values. And we want to construct a scatter plot of this bivariate data. It's bivariate because there's two variables, bivariate. So like I said, our low temperatures are X, our high temperatures are Y. Notice the scale for X is going up by 2's, and for Y is also going up by 2's. And just notice these little things here, we call them breaks. And that's just what allows us to jump from 0 right to these numbers, okay? You're gonna take a couple of minutes now and we're just gonna plot these points. So when our low temperature X is 26, our high temperature Y is 49. So low temperature is 26, so 20, 2, 4, 6. High temperature is 50. Well, if I'm going up by 2's and that's 50, that's 48. So right there at that point must be 2649. My next one is going to be 28, 50. So here's 20, 2, 4, 6, 8. And now I want to go 50 for my Y. I'm going to put a point right there. You're going to take a moment, pause the video, and plot the rest of the points, with your X being your low and your Y is your high temperature. After you've plotted the points, please continue with the video. So once you've plotted the points, hopefully your scatter plot looks similar to mine here. Would you characterize the relationship between low and high temperature as positive or negative? So is this relationship, it's definitely linear, is it a positive or a negative? Would that slope be positive or negative? I would hope you agree it's positive. And why? And that's because as X increases, Y increases as well. So what we're going to do now for C is we're going to calculate the equation of the line of best fit. Remember, this is an equation that allows us to make predictions. And our calculator is going to find the equation all on its own. We just have to be able to enter in some values. Mrs. Dupay is posting a video on how to do this with your just looking at your calculator, so feel free to go back and forth between these two videos. But I'm going to kind of walk you through it here as well. You look below in your notes right here, the little cheat sheet, and you can follow along here as I explain it to you as well. So the first thing we want to do is go to Stat on our calc, hit Enter, and we want to have our L1 and L2 clear. And remember, there are numerous ways to do that, one of which is just a cursor up to where you have L1 highlighted, hit Clear and Enter. And you could do the same thing for L2. And then I want you to take a moment and plug in the 10 low temperature values or X values into your L1. And then you're going to plug in the corresponding Y values into L2. So take a moment, pause the video, and enter those in. So hopefully you've entered those in. If not, pause the video and do it now. But if you have already, let's continue on with the actual calculation. Now, if you notice here, we can do this two ways. We can use option 4 or option 8. Okay, we're going to do both of them here. And you do whichever one you prefer. While they may look slightly different, you're going to end up with the same answer. Okay, so let's follow along and we'll do option 4 first. So I have my values in L1 and L2. The next thing I'm going to do is hit Stat, cursor over to Calc, and then we want option 4, which is linear regression. Once you see that, you hit Enter again, and you will see the equation of Y equals AX plus B with your with your A value, which here is your coefficient, and your B value, which here is your constant. Make sure the directions say to round to the nearest hundredth. When I do that, I hope you agree that my A, my coefficient, will round to 1.16. My B, my constant, rounds to 19.07. So when I write that as a linear equation in standard form, I get y equals 1.16x plus 19.07. Now that's all you have to do, but if you wanted to do option 8, it's the same idea. So let's all just do that together for this one time. So you have your L1 and L2 listed. You're going to stat, calc, but now instead of going to 4 linear regression, you're going to go to 8 linear regression and hit enter. And if you notice here in this one, your A is now your constant and your B is your coefficient. So although your A value here rounded is 19.07 and your B value rounded is 1.16, notice when I write this equation here in standard form, it's the same equation that I got for option 4, meaning my coefficient is 116, my constant is 1907. Either way, my equation for the line of best fit is y equals 1.16x plus 19.07. I mentioned it doesn't matter if you use option 4 or option 8. You use whichever one you would like. Just be careful to always write it in the proper standard form. So we have this line of best fit to help us make predictions. So let's look at D. We're going to use our equation, and it says if the low temperature is 50, what is the high temperature? And we're going to have to round to the nearest degree. Well, my low temperature, what variable is my low temperature? Well, we're using our equation. And if you remember up top here, my low temperature is X. So if my low temperature or X is 50, what's my Y? You're just going to sub that in. Feel free to use your calculator, round appropriately, and you get 77 degrees. So if the low temperature is 50 degrees, using our line of best fit, our high temperature for that day should be 77. For E, now we're still going to use our equation, but here they're telling me the high temperature is 32. And it's asking what is the low? Once again, we're going to round to the nearest degree. So if our high is 32 and we're using our equation, what are we subbing 32 in for? What variable? Hope you agree. 32 is our high, so that's my Y. We're finding our low or our X. We have a good old-fashioned two-step equation. Round your answer to the nearest degree. And pause, see what you get. Hopefully, you get 11 degrees. So on a day where the low temperature is 11 degrees, our line of best fit would predict that our high temperature would be 32 degrees. So your line of best fit we use to help us make predictions. We enter values or X into L1 or Y into L2, and then you do linear regression using option 4 or 8. I hope this video helped. I apologize for having 2 videos and they're both kind of lengthy. Please continue on and definitely try to do the exercise, check your answer key, and then move on to the homework. If you guys have any questions, please feel free to email any of the algebra teachers because we all are here for you and would love to help. Have a great day, guys.